Hey genius, I'm here back again to explain you the other two situations of exercise 1.1. So watch the video till the end and do subscribe my channel, hit the bell icon. If you like it, it would be great, and if you subscribe and share it, it will be wonderful. So before moving ahead and explaining you the other two situations, let's discuss and have a quick recap of our previous class. So, what we learned in our previous class. The first thing what we discussed was the 4 proven easy steps to solve any type of problem in exercise 1.1. So, these steps are very important, and if you follow it, you can get really good marks in your exams. In the next, we saw the general formula and we solved first two situations of exercise 1.1 of question number 1. So in this video, I'm going to teach you the two situations which were left out. That's the third situation and the fourth situation. So like we did before, I want you all to take a pen and a paper and solve along with me. So let's see the situation. So this situation is actually similar to the first situation which we discussed. So in this situation, the question goes like this. The cost of digging a well after every meter of digging, where it cost rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. So in this question, first, the initial amount to dig a 1 meter well, dig a well for 1 meter is 150 rupees, and then if you want to dig more than 1 meter, then 50 rupees will be added up for an additional 1 meter, which you have to dig. Okay, so let's see how do we solve this. So first, we are going to list out the given values in the question itself. So the first term what we saw is the cost of digging for 1 meter, which is 150 rupees, right? So that's the first term of our list of numbers, okay? So the cost of digging the second meter is 150 plus 50, which you have to add if you want to dig more than 1 meter, which is 200. If you add 150 plus 50, you get 200, and that's going to be the second term. Next term is the third term. If you dig the well for 3 meters, then you have to add another 50 rupees, which is 200 plus 50, which will give you 250. Next, the fourth term will be 250 plus 50, which is 300. Now we got the list of numbers, right? The list of numbers will be 150, 200, 250 and 300. Now we have to check whether these list of numbers form an AP or not. So to do that, we have to find out the common difference between these terms. Okay, what is the formula to find out the common difference? It's nothing but the second term minus the first term, which is 200. In this case, it's 200 minus 150. See here, 200 is our second term and 150 is our first term. So second term minus first term is nothing but 200 minus 150, which is 50. Now we have to check the common difference of other terms so that we can check whether it is constant or not. So the third term minus the second term. In this case, the third term is 250 and the second term is 200. 250 minus 200 is again 50. Now let's check for the fourth term and third term. Okay. So the fourth term is 300 and the third term is 250. 300 minus 250 is again 50. So in this situation, the common difference of the list of numbers which we got is constant. So since it's constant, since it's equal, the common difference is equal, right? It's 50. So we come to a conclusion that this situation forms an AP. I hope you all are clear and you understood how to do it and how to write it step by step. Okay. So let's see for this next situation. let's go to the next situation, which is about money, right? Everyone wants money in today's world. So let's see what this situation tells us. So according to this situation, the amount of money in the account every year when 10,000 rupees is deposited at compound interest at 8% per annum. So it's given that the principal amount is 10,000, okay, which is deposited initially, and the rate of interest is 8%. So as it is compounded annually, it's compound interest. First, we have to write down the formula of compound interest, okay. With the help of that formula itself, we can get our terms. So what is the formula? So the formula to find out the compound interest is amount is equal to principal into 1 plus rate of interest to the power of number of years. Okay, so in this case, the principal amount is 10,000. Rate of interest is 8%, so it's 8 by 100. It's in percent, so you denote it as 8 by 100. And the number of years we want is initially, we're going to count it out for 1, 2nd and 3rd year. So for the first year, it's going to be amount is equal to 10,000 into 1 plus 8 by 100 to the power 1, which is for the first year. So it's 1. That is our first term. Now for the second term, it's very simple. You just have to increase the number of years. It's year, right? So in place of 1, you can replace it to be 2. It's a very simple situation. So 10,000 into 1 plus 8 by 100 to the whole power 2. This is our second term. Next is for the third year. In place of second year, you just have to replace 2 with 3. That is our third term. Now for the third year, just replace the 3 with 4. You get your fourth term. So in this way, you got all the 4 terms. Now let's check whether this situation forms an AP or not. It's interesting, right? Yeah, it's fun. It's interesting to learn mathematics. To do that, let's see the common difference, which is the second term minus the first term. In this case, this term minus this term. So now, okay, the common difference, A2 minus A1, which is second term minus the first term. So once if you observe this very carefully, how can you subtract this? It's very simple, because 10,000 1 plus 8 by 100 once is common in both the terms. So you can take it as common. Once you take 10,000 into 1 plus 8 by 100 to the power 1 common, what you are left with, you can just write in the other bracket. So here you are left with 1 plus 8 by 100, because only once you have taken it out. 10,000 you have taken it out common. 1 plus 8 by 100, only once you have taken it out. So another 1 is remaining inside. So 1 plus 8 by 100. In this case, you have taken everything common, so nothing is remaining. So it's 1 minus 1. Now plus 1 and minus 1 gets cancelled, and you're left with 8 by 100. So what you get, the common difference is like this. 10,000 1 plus 8 by 100 to the power 1 into 8 by 100. Now let's check for the other 2 terms, okay? Even this is very simple. You just have to take down the common thing. But in place of once, you can take this term common twice. Okay, because it's common twice. So you take common, again you like cancel 1 and 1. And you get this as an answer. So this is your second common difference between the third term and the second term. Now, if you just compare this D2 with D1, it's not equal. The number of year here has been increased. It's increased by 1. So it's not equal. So in this case, this situation does not form an AP. So we saw 2 situations today. We solve it together and we come to a conclusion that one situation, that is the third situation, forms an AP. And in this case, this situation does not form an AP. And students, always remember, whenever you are solving this type of problems or any problem in mathematics, you have to write down all the steps, which is very important. Okay, with this note, let's stop it today. Tomorrow I'm going to teach you the next question. So do watch my video and don't forget to subscribe my channel to learn more and great. Thank you for watching. Thank you.